Okay, so in the next 15 to 20 minutes, I'm going to walk you through what I have built with respect to simulating the forward model of a social network. So we have kind of studied statistical inference before, but for as a refresher, um,
Swapnil, would you mind zooming the screen a bit,
yeah,
if
great.
possible?
Thank you. Let me do that. Uh, how do I, what was the, sorry,
I think it would be visible in view.
this one, and then I want this, right?
Yep. Yeah, no, it's better.
So, okay. So the general idea behind statistical inference is there is some world out there. There is a certain model that describes the way the world works. Now you have a model of the world. You don't really know how the world works, but you have some model for it. So you might say, people tweet every 5 minutes. That's my model of the world. That's not the right model of the world, but it's a model of the world. And if people tweet 5 minutes, then here is how, and if people like 10% of the tweets they see, those are two rules for the world I'm building. And therefore, if I simulate this, so if I have 10 people network, if I have 10 people, some network between them, and my only two rules for the world are people tweet every 5 minutes and people like 10% of the tweets they see, then I can actually encode these rules up in a simulator and run it forward to see what sorts of interactions will emerge in the network. The reason I say emerge is because this is stochastic. There is a certain probability involved. So they like 10% of the tweets they see with a certain probability. I can't predict exactly which 10% of the tweets they're going to like, but I can simulate it. And so there is this fine line between, like, there is an analytical solution for something or analytical description for something, and there is not. So simulations fall into the class of implicit models, where like there is a certain description of how the data is produced, but it is not like a mathematical equation. It is a simulator. And this is like a very fine difference to understand, because sometimes you can describe things perfectly despite them being simulations. So if I say, everyone tweets every 5 minutes and everyone likes the first tweet they see, and so not great, but like in some sense that is a more analytically tractable problem, because that is a deterministic rule, not a stochastic rule. If you like only the first tweet you see, and if I spread the tweets in chronological order of them being sent out, then that becomes a sort of deterministic system. What deterministic means is everything is predetermined, nothing is like random. So this simulation allows for randomness to enter the picture. And I don't think there's anything more I want to say about that, unless people want to ask questions about the difference between deterministic and stochastic and why simulators are useful. Okay. So the way inference works, like we were discussing before this, was now once you simulate some sort of outcomes, what you want to compare it to is the real world. And you want to say, how wrong am I if this is my model for the world and the real world is far more complex? The way you answer that how wrong am I question is by generating some data and then comparing that data to the real world. The inference question is, when you have real world data, you go back to the model and you say, if this was the data that this model produced, what were the parameters for this model, or what is your best estimate of the parameters so that they could produce this real world observed data. So two approaches to comparisons with data sets. The first approach is just like hand generate some data and compare that data to the real world. The second approach is get that real world data and infer the parameters of your model. That is a more powerful approach in the sense that you actually update your parameter estimates. In the previous approach, what you would have done is just keep regenerating data, change something, regenerate data, change something, until you get to like a good representation of the world. which is like if I've seen Jay like 5 tweets, then I want to simulate Jay liking 5 tweets. And until I don't simulate that, I will keep rerunning my simulation and changing my parameters. What inference does is allow you to do this in an automated fashion. So it will say, conditioned on the fact that Jay liked 5 tweets, what could have been the generation procedure in this world? Tweet generation procedure. And that is exactly what I want to simulate. So I'll pause there for questions. Okay. In which case, let's walk through some of the code.
Swapneel, I do have a question if you have a moment. So is there a standard way to measure when you're doing a simulation how accurately your simulation represents the real world data?
Yes.
Yeah. So and you're going to go into it then, I take it.
Correct. I haven't done that yet in this code base, but yes. So the way you would compare that is there are certain divergence measures for data sets that tell you, given like how divergent is one data set from another data set. You can also think of it as a loss metric. For example, if you have retweets in time for one data set and you have retweets in time for another data set, just comparing how different the two are in terms of like one minus the other. You can compare the root mean square error. You can compare the cumulative retweets. So if I have 500 retweets of fake news in the real world, did I get 500 retweets of the same fake news in my simulation? So there are different ways of evaluating. I think people bias by what works best for their setup. So population level stuff works well for some people. Individual level stuff is much harder to get right, as you might imagine. So if I want to study retweets, I would rather study retweets in the entire network of this fake news than going and looking at each individual person and saying binary yes or no. Did the person retweet, and did the person retweet in real life? That comparison is much harder to get right. Tell me if you're following this.
I'm following. Thank you very much.
Sure. Cool. So individual level and population level evaluation metrics. What we want to get at first is like, what is this simulation? So let's start with a very simple random. So all of this is randomly generated because I'm trying to get to create some ground truth and then see if I can recover that ground truth from the observed data. This is something we hit upon in Shalizi stats, but generally the way the way simulation based inference works, or the way you frame your problem, is you create a true model of the world. This true model can be very complicated. This true model can be very simple. Then you forget about this true model and you only use the data that you've generated from this true model. With this data, you go back to what you're actually building, your learning approach, and you say, look, there is some real world data. I'm going to assume this is from the world because I built a true picture of the world that I've now forgotten about. What I want to do is then use this data in my estimation procedure and see if I can recover that true model of the world. So I am, in a sense, I am God because I control the world. And then I want to see if I can recover that picture of the world. And if I can do this in a simulated setting, that gives me much more confidence over actually going to the real world where I don't have any idea what the true model is. And then looking at some observed data and saying, okay, based on this observed data, here is like a picture of how the world works. Okay. Okay. So there are 3 stages in this process of like model building. One, we sample a random graph and a random network on top of it. This is again building a true model of the world. 2, we assign beliefs to all of these people in the network. So beliefs are basically a random variable that indicates where they lie, say on a left to right spectrum, where like left is indicative of pineapple pizza haters, right is indicative of pineapple pizza lovers. Um, so the blue and red colors maps to pineapple pizza lovers and pineapple pizza haters respectively. So red is haters, blue is lovers. Now going forward, because you've given each of these people this belief in pineapple pizza, we can generate tweets sampling from a distribution parameterized by these beliefs. What I mean is, if a person is 0.8 on the scale, which is towards 1, which is pineapple pizza lover, then they would probably tweet somewhere in the vicinity of like some distribution with mean 0.8 and like some variance. I don't restrict these things in the sense like there is no high and low boundary, but I'm just giving you an example of what how tweets are generated in this setting. Once tweets are generated, we have some rule for retweeting. The way retweeting works is we compare. So now that a tweet is a sample from a belief distribution. So the belief is a number, the tweet is a number. What we want to do is on someone seeing some other person's tweet, we want to compare how close this tweet is to this person's ideology. So in this case, we take a certain log probability of the tweet from the belief distribution parameterized by that person's belief. So the question we are asking is, how likely would this person have been to generate this tweet? And if this person was very likely to generate this tweet, then it seems very ideologically similar. If it is ideologically similar above a certain threshold, then the person is very likely to retweet it. So ideological similarity, beliefs, tweets, and retweets. Any questions so far? Cool.
So one thing that I had wanted to ask, so like, wouldn't the belief like would be like, let's say, very subjective, right? Sort of like, let's say, based on individual, or like basically depending on like the population groups that you are, let's say, learning the simulator for, right? It won't result in a like a generalized model, right? Or simulation too, right? So how do you like basically try to manage that probably, or like do you restrict your study to a particular population group only for now?
So great question. Firstly, yes, I do restrict my study to a certain population or group. Secondly, there is a concept of ideology that has been studied on a bunch of Twitter users, like millions of Twitter users, and there is a principled approach to estimate the ideology of a person based on the network of people that they follow. Um, Sorry, go ahead.
Yeah. Go on, sorry.
So using this, what they derive is ideology is a certain latent dimension that they measure. So they say ideology is something in your head that drives you to have the thoughts and opinions that you exhibit. And we measure that by using the people that you follow, because we think you follow people who think like yourself. So what they do is, like, in a big network, they have like 100 politicians, and politicians they can put on a spectrum based on, because they have voting of politicians on different policy issues. So once you associate a number to a politician based on this scale of where they have voted, or how many, or left to right, what spectrum do they fall on? Because there are some leftist policies, there are some right policies. So voting will indicate from -1 to 1, for example, where on a spectrum they lie. So once you have these politicians' ideologies, you can trickle that down into the network. So if you follow 3 of these politicians, your among other people, your ideology is probably like based on these 3. Here's your ideology, and so people who follow this person now will in turn be affected by this person's ideology, and so on. So it cascades. So that's how they estimated the ideology of a large number of Twitter users.
Okay, but like, what if maybe there are extreme cases? Like, suppose let's say there are like there is a person, suppose like that follows 2 different ideologies, and how do you come up with like an agreement between like which one is more dominating than the other one?
That's a great point. And I think what they do is they estimate the ideologies in a cascading manner, which means that they get a lot of ideologies for people's networks.
Mhm.
So
Mhm.
based on that, it is fair to say that this person, while they follow some actors in the opposite direction, most of the people they follow are in this particular direction. Therefore, here is how I estimate the ideology.
Okay, yeah, because this is more like people can have different perspectives about things as well, right? So they like don't like reject the other opinion as well, but they like basically let's say weigh one more than the other, or like prefer choices. Probably.
Yeah, completely.
Yeah. Thanks for the
Uh,
clarification. Yeah.
I have one question.
Go
Like
ahead.
for the analysis and loss function, and to classify people as having belief system closer to left or right, we need to actually classify the topic itself, right? As in, if people are supporting this, then they will become left, and then they will become right.
So
That will be the crux of the model.
the nice thing about that is we don't have to do that because the left and the right have made it very clear what policies are theirs and what policies are not theirs.
Okay, so you're saying manifesto could be taken into consideration or something like that.
Yeah, basically, like it there are certain types of stances that are very commonly observed on the left. For example, a liberal policy might be to tax the rich, whereas a conservative policy might be that the rich people are not getting taxed as much. A liberal policy might be pro-abortion. Conservative policy is very likely anti-abortion, and this is exhibited very clearly in practice, where like um, uh, for example, people who support the CAA in India or the NAC CAA, right? So people who supported that were likely like supporters or allies of the BJP, or maybe they were kind of anti-Muslim sentiment. I'm not. Maybe I'm generalizing, or maybe I have the wrong understanding. But to my knowledge, that seemed to be the case. So yeah, so basically policies are very well known to be um, um, brainchilds of certain parties, and by doing that you associate a concrete measure to the starting point or the pivots. Not I shouldn't use a term because I don't remember what they used in the paper, but the starting points for like estimating these ideologies in the whole network.
Okay, thank you.
Sure. This ideology estimation paper was actually a paper at my lab. um, um, Very cool stuff. It worked really well. Lots of people use it. Cool. So once you have retweet based on this ideological similarity, you can, for the record, this is like a model. It's not necessarily the right model. So you can change things around and build your own approach to ideological similarity. And with that, we get to a point where we now have a graph. We now have the network on that graph. We have the beliefs for the people in that graph. And now we actually want to start simulating some tweets and seeing how the network kind of evolves. So I wrote up a tweet generation process that might be broken. So I don't want to get into that, but I'll get to, uh, yeah, I don't think I committed a stable version yesterday. Okay, so getting to a point, so there is some generation code for videos of how things work. Um, yeah, I think simulating belief updates is the first part to start with, and then simulating binary exposure is the second part I want to get into today. Cool. So simulating belief updates works in this. So there are three components to our graph. One is users, two is networks, and three is bad actors. Bad actors are randomly placed around the graph. Um, Bad actors are shown in black here. Um, I might have, I think I need to step away for a couple of minutes. Give me 5 minutes and I will get back to this. I need to pause recording. Resume. So we have actors, we have networks, we have tweets. Tweets are being sent out, and what I missed out on saying before, which I'm repeating for the recording now, is that there is a certain belief update that happens when a person gets exposed to certain tweets. It happens in a manner similar to how we generated retweets, which is like we compare how ideologically similar this is, and therefore how much influence is this tweet going to have on this person. Um, And so with that, this person's placement in this network, because this is from right, left to right, the placement changes, which is where the network starts moving around. Either it moves further apart because they reject the belief, or it moves towards that person who has sent the tweet because they buy into that belief. So simply put, not this one. Simply put, what this gives us in time is something that looks like this. This is, it is T0. The condensing and expansion was basically just an artifact of video generation. I have not solved that yet. But anyway, what's happening in this network is like bad actors are not changing their positions. It's actually the frame of reference for the camera that's changing, but everyone else is actually changing their positions and moving towards the tweets they are exposed to or further away from those tweets. And this is like, you can simulate a bunch of different things. In this case, now I'll get back to what I have already shown you before and shared with you, but now hopefully it has more context. So bad actors causing polarization. I think this is, yeah. So bad actors can target their messages to certain groups. In this case, the bad actors are the pineapple pizza mafia. What the pineapple pizza mafia wants is they want everyone to get addicted to pineapple on pizza. So everyone should go towards blue. So what they do is they target their messages towards the people who are most likely to be affected by it. And so people in the white region are kind of neutral, so they are very likely to be affected. So these bad actors are now pushing those people. As you can see in time, all of these red people are slowly and slowly changing over to blue. And this is like we just, again, this is a simulation. So this is what happens, or what we think might happen in the real world on social media, where these politicians are pushing misinformation to pro some politician or anti some other politician, to push people in a certain direction or to influence beliefs. And there's a lot of literature on like belief manipulation and like how it works. There are case studies and all of it, but I do not believe any of them use agent-based models because it's just really hard. And now we'll get to the part where like I'll talk about inference.
So, do you think this seems more like the simulation, like gives you an observation about like, let's say whether this like the belief changes more of like a nearest neighbor based like update sort of thing, where like let's say someone who is like let's say more kind of what I'm trying to say. So, which is very close to this, like let's say this black, the bad actors, like is more likely to like update, and then later on, like it will again push the others, like which are very closer to its group and like so and so. So, do you think, or is it like not that way?
I didn't completely follow what you said.
So, like I'm trying to like basically make a sense. So, is the observations like basically very similar to nearest neighbor, like basically in terms of like how the belief changes? So, like the idea
Belief
being.
changes are what it gets exposed to. So belief changes don't have anything to do with neighbors. Um, Belief changes are if you see a certain tweet, how likely are you to believe it based on your current belief?
Okay. But that would be also based on like the notes and links associated right with that particular topics and things, right?
Yes. So in this case, we've just randomly placed belief on people. We haven't actually connected beliefs and their networks. But if you were doing ideology estimation and using the method that people have written about, the one we mentioned before about networks and cascading networks, then yes, your network would dictate your ideology, which in turn would also be used for belief updates. Therefore, your network would be used for belief updates.
Okay, so like you are basically trying to eliminate all and like directly throw an agent model and like simulation and like directly figure out, like let the agent model figure out based on let's say some starting point that we have, like what the observations might be.
Exactly.
Okay,
So the
makes
challenge with
sense.
this is that there are first, as you might have realized by now, there are a lot of assumptions we have to make about how tweets spread, about how people update their beliefs. And so I tried to reduce it to a problem where like I have measurable data. So measuring beliefs is not easy. Measuring beliefs a lot of times involves actually surveying people. Like, what do you feel about this topic? How do you feel about this other topic? So on and so forth. The problem with this is you can't survey a lot of people because it's really expensive. Secondly, people lie. Thirdly, people don't respond to surveys. So it's really hard to use survey-based methods in scalable computational social science. So what I want to study, I study in terms of what is already available on the platform. One of those is behavior. So what do I mean when I say behavior? What I mean is their retweet frequency, their like frequency, their tweet generation frequency, their session duration, those kinds of things. So these are actually measurable statistics from the platform. And I'm actually also switching my use case to Reddit because Reddit data is much easy to scrape at scale. And we have Reddit data dating back to 2008 compared to Twitter data, which is one, expensive, two, takes time, and three, might not actually be available to us. So the Twitter part I want to keep, because Twitter is cool and it's actually possible to do this with Twitter data. It's just a question of it will take time. So that is like a long-term project I have, where long is equal to 6 months. So it's not really long-term, but yeah. But Reddit data we already have in hand. So that's the use case I'm now transitioning over to. But the method is the same regardless. So regardless of what observed data set you use, there is still a certain model that you will fit to this data and the parameter estimates that you will obtain. So yeah, with that, I've mentioned behavior, but I've shown you simulations of belief only. So just for completeness, let me show you what behavior is like. So maybe not this one. In the graph, so now what I care about is just exposure to misinformation. And because my research question, if you remember, was how does exposure to misinformation affect the behavior of a user? In terms of simulating exposure, now everyone in this network is just an agent. So everything is white. There are some bad actors in this network. The bad actors or bad accounts are going to send out tweets to these people. And based on who gets exposed to these tweets, they become pinker and pinker. So all that matters is exposure. And then we track how their behavior changes when they get exposed. So these, if you can see, the light pink networks are the retweet networks. So now I care, because I care about behavior, I've also like focused on simulating retweets. And so the network evolves, people get pinker and pinker based on exposure to misinformation. And then it ends at a certain point where now we have two things that we have gathered from this network. One, we have the X. They're not run. Oh, I didn't run everything. Let me give it. I think it shouldn't take too much time. Otherwise, I can just open this. Cool. This is exactly the page I wanted. This is great. View. Oh, it already worked. Nice. Nice. So you can, just as an example, like you can see in time that the bad actor is tweeting and people are actively retweeting this misinformation. So what we track, one is in time, how many retweets did this piece of misinformation get? So from 0 to say 50 hours after the tweet was published, how much was the tweet retweeted in time in the observed world? And the blue thing is what we actually simulated. So the question to ask is like, if this is the observed data, then does our simulation actually match up to it? And in this case, it kind of does, because you see the peaks are corresponding, which is because all the data is fake and I actually created something that looks really nice. But this is how you would evaluate your analysis in the real world, where you get this set of observed retweets and you compare if that trajectory matches yours. Another thing you could compare is these individual level trajectories. So there are some people who are bad actors, which is why their exposure is one. But there are other people who slowly get exposed to misinformation in time. So on the y-axis, I have the fraction of how exposed they are to misinformation. And on the x-axis, I have time. So in 0 hours, 5 hours, there are some people who get bumps, which is they are exposed to misinformation. More bumps, more bumps, more bumps. On average, like people start getting more and more exposed to misinformation. And so the goal here is just sort of examine individual trajectories where I care about this person. Oh, I care about this person, so I'll look at that trajectory. Maybe I care about this person, so I look at that trajectory. So like it's possible to study the individual level effect of misinformation being spread through this network on these people. Now, before I get to the last part, which I actually haven't coded up, I want to pause for questions.
So could you clarify once, like, how do you decide whether like a tweet is misinformation or not?
That's a great question. So I don't decide that. I use fact-checked tweets and fact-checked URLs to create this data set of misinformation being tweeted.
Okay.
But that is a very deep question about what is misinformation and who decides what is misinformation.
Yeah. Yeah. Right.
Okay, so one piece that I have not explicitly mentioned so far, but I want to study in the future is, so far you can see like these tweets are spreading all across the net, all along the networks, and the retweets are also spreading all along the networks. But like in practice, what happens is your timeline on Twitter is dictated largely by recommender systems. It is not dictated by like all of what you see in your net, all of what your network is doing, unless you like explicitly select reverse chronological order, which very few of us actually do. So what Twitter does is it uses a ranking and relevance system to show you the best tweets that are relevant to you. So there are systems in practice that are actually studies of how recommender systems might work. And in fact, so basically what we want to do is plug in a recommender system, and per user we want to dictate what tweets their timeline is likely to see based on the available set of tweets so far. That is a challenging problem, but like it is the fact that the framework allows us to do that is really good, because that means we can study these kinds of problems and we can create an end-to-end simulator of like, here is how we think a simulator might work. Again, I say might because we don't know what is the real model for the world, but our goal is just fit the best model that we can. So for the purpose of like Unicode research, what we want to do is, one, create a sort of Twitter scraping framework that gets us tweets for the users that we are interested in. Number two, what we want to do is use these tweets to fit some individual level model. So like if you can you model tweets on an individual level. Number three, what you want to do is get some sense of network of these users so that we can simulate tweet spread within this community. And number four, what we want to do is now try to plug in a sort of recommender system so we can say, oh, based on user features, these are the topics that this person is likely to engage with. These are all like questions that you might write individual papers about. So we really want to carve out meaningful sub questions out of it. But I also like, I don't want to do this for you. Like if again, I'm going to do it anyway because this is my research project. And I'm going to continue working. This is my thesis project and I'm going to continue working on it. But if you're interested and you want to throw around research questions that we can ask with this sort of setting, then I'm very happy to discuss like what is practical, what we can do, how much time it might take, and so on. Like I said, especially with Reddit data, we might not have to do a lot of scraping. So if you want to get started on that front, we can build the Twitter scraper, let it do its thing, and then meanwhile just start working with a different data set while we collect our own custom data set. So yeah, I think that's all I want to say. I will share this code base now that I have given you an overview. I think it's good for you to jump into it. So um, pass me your sorry, pass me your GitHub handles and I'll give you access to the repository.
And one more question that I had. So, like, don't you think we should actually um, like do this sort of simulation on Facebook related data as well? Because that is also one more major source, right, of how the misinformation is spread.
That's a great point. In an ideal world, yes, we do want to compare multi-platform data. So this thing, the information tracer is our friend,
Yeah.
because there we can actually pick a URL and see how it's spread across multiple platforms.
Yeah.
I don't want to jump into that challenge directly because first you guys will end up confused about like you need to understand one platform before jumping to multiple platforms, because this goes down to a question of, well, on Telegram there are channels, there are not users. On Facebook there are groups, you might not actually see some of them, you might see others, and so on. So there are modeling choices that we have to make, but before that I want people to understand the concept of building a model of the world, simulating something. We still haven't discussed inference and how inference will work. I want to table that discussion for next time. By the time you get like experience simulating, then we can go to the inference question.
And like, so currently whatever experiments that, let's say, the simulations that you have like prepared, so that is just for text support, like supported for text only, right? Or like is it multimodal based simulators?
This is not a multimodal simulator, so it's just a text simulator. You're right.
Okay,
Yeah.
okay.
So another modeling choice you might make is, do we include or do we not include videos? And if so, like, do we want to like simulate some sort of just presence or absence of an image or a video? That is something we
Yeah.
can simulate. That is something we can measure. So
Yeah, yeah. Because like the point being, I was getting at, so there is some like sometimes, let's say an image or text isolated, it is not like a misinformation or hate speech or something like that. But like both of them combined, like can be sort of like misinformation or like something like that. Right? So like
you're
the
absolutely
ideal
right.
way be to consider like all the modality content and then decide okay which one's like basically is misinformation and which one is not.
You're absolutely right. Yeah. But again, like this is something I would bite off after I have everything basically chalked out.
Yeah, that's true. Yeah, first, like, let's work in single modality and see if it works, and then yeah, we can later on migrate to multi.
Make sense?
Yeah,
Cool. I have your handles. Cool. Any other questions?
I think yeah, that's it for now. We'll go through the code base ones, and yeah. So apart from this, like this is questions for like that causal predict. So are we discussing like anything about it today, or like this will be like
So I didn't
discussing
see
next week?
anything on the agenda about like updates to it, so I have not checked. Is there stuff we should discuss?
So like the idea was that we'll update the questions right based on that, and like let's see. But I think yeah, we haven't done so. Probably I think well, let's discuss about it next week. So we'll also like if we go through it and like make a final list of questions too,
That sounds good.
and like yeah,
Yeah,
and
and,
start releasing the server. Yeah, yeah.
feel free to ping during the week and like tell me what I should prep. If you have like added updates here, then I would need to know like what those updates are to like go back and read the sheet, because I don't see anything here. But
Okay.
maybe, yeah.
Yeah, yeah. I'll post the agendas for like next week as well, and like update, put the updates on the group as well, Discord.
Yeah. And once like you guys are set with this, we might want to consider like bringing on like 5 or 10 more interns who want to work on these kinds of projects from probably from second years or something, because they have more time. So that one, teaching them is the best way for you to learn. Number two, you might want to spend less time on like doing these projects and like more time on some things you already have going on. But like you would still want to be involved. So like the best way is to involve a certain third party. And three, like it's good for them to be involved with research projects. So I'm sure that should have been one, but
Uh, yeah, I think we were planning as well, like right, basically to integrate like juniors as well. But like yeah, we are waiting for like us to make some progress, and then like basically let's integrate once we have few ideas, so then we can like basically distribute like the projects among them, and like we can mentor.
Yeah, makes sense.
Yeah. So you were also saying, right? You will also try to get some PhD students if they are like having some projects
So
within programming.
one of
Yeah.
the things on that front was this friend with the car project. There was Johan wants to do some things with the information tracer, but again, that depends on when we get back to him and like what we want to do with it. So I need to hear back on both those things. I will invite my friend with the car project next week or the week after that because it's Christmas out here.
Mhm.
But yeah,
Okay. But so don't you think like your project and information trees are very similar? So like why not like later on let's think about integrating both of these pieces together?
definitely. So the reason I don't want to start off with that is the bigger the bite you, the first
Yeah,
bite you
yeah,
take, the harder it is to.
that's yeah, that's like yeah,
Yeah, but yeah, I don't think that's a bad idea in the future.
yeah.
Cool.
Can I ask one question related to the presentation you had?
Yeah, go
Um,
ahead.
so I understood where it is ending, you know, like how the bad information or misinformation is spreading. But like do we consider to take a consideration on, because like when we spread misinformation, it could be like people are sharing or retweeting to make people aware that this is a misinformation, or people are actually sharing it because they think that is true. So like do we take both of them in consideration into one bracket, or do we think differently?
That is an excellent point, and I think that would be a great like first bite if you want to like update the simulation, because it's like 2 lines of code exactly that you need to add. Um, um, 4 lines of code to be more precise. But I think that would be a great first step. And I think the reason that I should like the reason I'm sharing access is so that you can go about this process of creating an issue. On that issue, we can discuss what you want to do, or creating a feature request or something like that. It's still an issue, which is called a feature request under the issue. But discussing what you want to implement, going back, changing, like creating your own branch, updating the code base, and then we can discuss what the simulation looks like. But a more structured approach than like, oh, you propose it, I say yes, great idea, then you go back and you implement it somehow somewhere without like understanding some parts of it, you come back, I don't understand some parts of it, and then we end up confused. So this is a great idea, and I would encourage you to start on like an issue in the code base so everyone can see what is going on. And this is also how development works in like large public libraries. So
So, but until now, we are we focusing before finishing this simulation, right? Or are we actually working on continuing those issues?
So we can do both. The first thing I want people to get experience with is like forward simulation. The second thing, and this is mainly because I haven't completed like a good enough version of this inference stuff to share with you. And I don't want to confuse you with broken code. That's the reason I skipped a bunch of parts of this. Um, but yeah, so I want to focus on forward simulation. Then 1 or 2 weeks after you get experience and implement some sort of features additional to this, then we can go into inference.
Mm-hmm. Got it.
Cool. Thank you. That was a great question. Okay. If there are no others, then we can actually end the call here and I can give you back some time. All right.